Hey guys, Easy Science here. Studying for an exam or just learning for fun, you've come to the right place. Today's topic is on an atom. But how was it found or discovered? Or the historical purpose, perspective of the atom. I did a video on the atom quite a long time ago, or my first video, but it was pretty old, so I might redo it, but today we're going to talk about the historical perspective of the atom. Well, to get a base at the start, a couple in the ancient Greece, everyone, or not everyone, the ancient historians, well, the Greek thinkers Leucippus and Democritus thought that everything, all matter, was made up of infinitely small things, which we know now as atoms. So, hence, even that long ago, people still thought of atoms. They didn't know that they existed, but they knew of the idea of atoms. First off, man named John Dalton, or more precisely, a scientist named John Dalton. He was born on September 6, 1766, Eaglesfield, Cumbria, United Kingdom, and lived a long life until July 27th, 1844. He was most famous for what he called the atomic theory. That was the real evidence, first evidence of atoms. So, now let's see what the atomic theory is. So just to start off, Dalton's atomic theory was basically the first clear, complete attempt to solve for or give a theory for the atomic structure, or to describe everything, matter, in terms of atoms and their properties. The first part of his theory is that all matter is made up of atoms, which are indivisible. As you know, atoms are smallest particles that you can that well, not the smallest, but matter is made up of atoms. Everything lighter than that or smaller than that is discrete, and we shouldn't count it for this topic. So, when it is indivisible, it can't devise itself. That's why they stay so nicely in chemical formations and crystal formations. And also, if something happens with the atom, that's how when nuclear fission or fusion happens, that's why large atomic explosions are created because of the massive energy released. The second part of this theory is that all atoms of a given element are identical in mass and properties, which means that an element is something with a specific number of protons, or an atom with a specific number of protons. Since protons can't be half protons or quarter protons, it's always ones, multiple of ones. That means that if you have a proton with 50, an atom with 50 protons, it's gonna be identified by the element that it is identified by and can't change because of that. For example, copper has an atomic number of 29, atomic mass of 63.55, melting point of 1085 degrees, and 8.9 grams per centimeter cubed. So, all atoms with 29 protons are copper. That is proven because if it has 30 protons, it is a completely different element. Third part is that compounds are combinations of two or more different types of atoms, which means two or different types of. So, like the basic compounds that we know is water, paper, let's say, gasoline. Those are all compounds because they're combined with different types of atoms or elements. For example, CO2, H2O, water, has two hydrogens and one oxygen, which is just a combination of both types of atoms, making the compound water. Chemical reaction is a rearrangement of atoms. That is true because when a chemical reaction happens, let's say you heat up water, H2O, you heat it up. If it starts to boil, oxygen starts getting released. So a chemical reaction is a rearrangement of atoms. Or let's say something better. Let's say tree, or let's say, even better example, something like propane. Right here we have propane. When it reacts with oxygen, when you burn it, oxygen is in the air, which is part of the fire triangle. Oxygen, heat, and fuel cause a fire. So when you make a fire, it gives heat, fuel, which is propane, and oxygen. When you light it up, the propane goes away, and the atoms of the propane rearrange to CO2, which is carbon dioxide, and water. Sorry. C, as we have H. We have H atoms, which combine with the atoms from the air. Same with the C carbon atoms, which combine with the atoms in the air, which they rearrange the atoms in the propane to cause it to give off new compounds, or not new compounds, but just rearranged compounds, which means in a chemical reaction, no new things are created. That is very important, since just rearrangement, nothing new is created. This atomic theory is important because it gave a start to many other theories and many other concepts in helping develop new technology, nano things, etc. So this is a very good base to atoms, and it is the only theory that we know of right now. The other theories were debunked. Dalton, the man that made the atom, based most of his theory on the law of composition. It states that a chemical compound always has the same ratio of its feeder elements or atoms, component atoms, in fixed ratio. So if you have 100 grams of oxygen, it would always react, so let's say 100, it would always react with 133 grams of CO2, carbon, to make CO, then would react with 266 grams to make CO2. He based this, and using this, he said that compounds are just a rearrangement of atoms. Remember the scientist I was talking about, Democritus, or the thinker from Greece, the Greek thinker, about 400 BC? Well, Dalton focused a lot of his theory on his theory of the universe. All matter consists of atoms, which are bits of matter too small to be seen. Like I said, he doesn't know of atoms, but he knows the idea of an atom. There's empty space between atoms. Yes, since if they were all clumped together, they couldn't really move. Atoms are completely solid. atoms have no internal structure. Well, there he kind of messed up because they have electrons, but Dalton didn't find that out. The person that found that out was J.J. Thomson. Each atom is indifferent in size, weight, and shape. That makes sense because when an element is always different, just like John Dalton stated. So now J.J. Thomson was the man that discovered the electron and used a cathode ray tube to discover it. So basically, electricity passes from cathode to anode, and anode is positive and cathode is negative. A small amount of electricity passes through the hole in the anode and reaches the phosphor coating. So with his procedure, it went like this. He took a nearly empty tube, or almost a vacuum. An electric charge passed through the tube, it travels from cathode to anode, like I said. The charge is invisible, and where it traveled, a fluorescent screen is placed at the back of the tube, right here. This beam will always travel straight if not interfered with. So it is like a line in math. The deflection coils each have a specific charge. There's no really deflection coils on here, but on his experiment that he did, one is positive, the other is negative. Thomson showed that the charge would deflect away from the negative coil. He then stated that this charge was thus a negative charge. What he did was interesting because if there's another negative charge on there, he knew it was, and if he passed electricity through and it deflected off of it, he knew that they were the same thing. And from that reason, he found out that electrons existed. And he knew that if there was a positive charge, there would also be a negative charge. Okay guys, I don't want you guys to lose education, so I made a bunch of questions for you. You could read them out and put your answers in the comments below. I will go over them in a separate video if you want me to. Okay guys, thank you for watching this video. I really appreciate it. If you like this video, please leave a like and comment for new video ideas. If you want to see more videos like these, subscribe and I'll be posting almost every day when I can. Easy Science out.